So I've got several anecdotes of my early days in the different labs that I trained and so forth that I think would be interesting for, young people to. So it goes into the, how do you become a scientist playlist, if you will. The question is, if you're a young person deciding to go into science. So I spoke in one of the previous videos about going to graduate school versus medical school, and becoming a physician first, and then going into postdoctoral years. And after graduate school, you got to go into postdoctoral years as well. And so I thought we could talk about at least what my experience was in my postdoctoral years, medical school and postdoctoral years, that sort of pointed me on the path to become a scientist. And what I found in a general sense is that the whole thing is very idiosyncratic. It depends on who you're dealing with. And as I said, particularly the graduate school years and the postdoctoral years are an apprenticeship. And so a lot depends on your mentor and what stage of the career that person is at and the size of the lab. And when I started out in this whole process, when I was a third-year medical student, I ran into a fourth-year medical student, and it was just at the beginning of my third year. I was just on one rotation, and it happened to be an infectious disease. And I ran into this senior, to the fourth year student, and he was all excited because he was applying for internships and so forth. He said, "Well, where are you going to go for your internship?" And I said, "Well, I don't even know what kind of a doctor I want to be, let alone where I want to go for my internship." And I said, "Well, but I do know what I don't want to do." And he said, "Yeah, what's that?" And I said, "I don't want to go to Vietnam." Because I had just been married a couple of years, and the idea of leaving my high school girlfriend, who was the love of my life, and going off to Da Nang was not a very good idea to me at the time, anyway. And he said, and so my fourth year student said to me, "Well, if you don't want to do that, you ought to go to the NIH." And I said, "Well, what's that?" So he explained to me that it was the National Institute of Health. And that if I went there, for 2 years, that would serve as my military service requirement, because they take you into the public health service, which is one of the arms of the armed services. That was actually established in 1798 by John Adams to take care of the merchant seamen, because they were getting blown out of the water on the Barbary Coast by pirates and all these other things that were happening. He needed something to care for these poor people when they would get all banged up. So that was the beginning of the public health service. And so I said, "Well, okay, how do I do that? And how do I get into there?" And he said, "Well, there's only one guy here at our medical school who can get you in, and that's Chuck Mingle. And he's the head of hematology and oncology here. And he said, you should go and talk to him and see, and tell him what you're thinking about doing and so forth, and see what he has to say." So he said, "But if you do that, don't tell him that you don't have any idea what you want to be when you grow up." He said, "What you've got to do is tell him you want to go into academic medicine, you want a really good internship, and you want to go to the NIH. And if you tell him that, then maybe he'll help you." So that's what I did. So I went to talk to Chuck Mingle, and Chuck Mingle, I'm not a very tall person. I'm only 5 feet 4 inches tall. Well, he's 6 feet 4 inches tall. Big guy, very, very, very strong. Comes at you with he's a lot of charisma and presence. When he would walk into a room, everybody would sort of say, "There's somebody is here." So I went to him. I told him what my friend told me to tell him, and he said, "You do, huh?" And I said, "Yeah." And he said, "Well, if you want to do that, then you have to come and work in my lab your entire senior year of medical school." And I said to him, "Well, if I do that, what am I going to do during my internship? I'm going to not get very much clinical experience." And he said, it's a piece of cake, easy. He said, after the first 6 weeks will be tough, but then after that, you'll get the hang of it. And actually that was the case. So One of the things that I think I should probably reveal in my career path was that when I went to medical school, I had heard it was really, really difficult. And so I vowed to myself that and I was worried that I was going to flunk out. I studied night and day, really. I mean, we had classes between 8 and 5. I'd come home. I had one of my high school friends. I roomed with him my first year of medical school. He was a dental student and I was a medical student, and we'd come home, we'd cook dinner, we'd be done with dinner by 6, and I would study until midnight. Just did that the whole time. Saturday, Sunday I had all day to study. Consequently, I did very well. Particularly my first year, I won the award for the most outstanding first year medical student. And I just kept on, I was on a roll, and I just kept on that roll. And consequently, I ended up at the top of my class in medical school. And an interesting story about that, because I graduated summa cum laude. And when they told me that there were 2 other people that were also summa cum laude, I said, well, who are they? And one of them was my very best friend from high school, whose name was Jeffrey Wardwell. And we were high school buddies, and then we went to the same college and were freshman roommates. And then we pledged the same fraternity in college. And then we went to medical school together, and then we ended up at the top of the class together. And so we wanted to know. I mean, immediately we said, okay, well, who's number 1 and who was number 2, But they wouldn't tell us. But both of us knew who was 1 and who was 2, right? The reason that's important is that I don't want to leave the impression that it was all luck. Me running into the 4th-year student on the quadrangle when I was a 3rd-year student and so forth, and him telling me that I should go to the NIH. Because at that point in time, I was already recognized by the people at my medical school that I was one of the best students, so that when I went to Dr. Mengel to have him help me get a good internship and go to the NIH and so forth, that facilitated things for sure, because if I'd been at the bottom of the class, I don't think I could have taken that route. So I went to his lab and worked. I had to do 2 rotations during my senior year. One was surgery, senior surgery, and the other one was psychiatry. That took up 4 months of the year. So the rest of the year, I worked in his lab and I did experiments. He was a hematologist, and I did experiments on mice. And it was my real first experience in a laboratory, and I sort of liked it. I don't think that I was necessarily all that successful, but at least I had an inkling about what science was about versus what medicine was about. So in talking to him during that year, I said, well, I'm not so sure I really want to go to the NIH, and I shouldn't have said that to him. What's the matter with me? But he said, okay. So you want to go to Georgia and do rectal exams, or do you want to go to Washington or Baltimore and do science? And I said, well, when you put it that way, so that was my introduction, and I never forgot that. So you want to do rectal exams all your life, or whatever? Oh, absolutely. Now there was one other story during that. In my junior year, my 3rd year, ultimately after that first rotation in infectious disease, I was on internal medicine for a couple of months, and I should preface my comments by saying, I think people sort of steered me into this path, very gently, not with a big sledgehammer saying you got to do this, but it's sort of like, why don't you try this before? Maybe you'll like it. And I had a really interesting patient when I was a 3rd-year medical student who was, it was very dramatic. He was an alcoholic who came into the emergency room gasping for breath, and because he was very, very anemic. And so it's sort of like the COVID-19 patients right now. He didn't have enough red blood cells to carry the oxygen around, and so he was just hyperventilating and gasping for breath and so forth. They called me down to the emergency room to introduce me to my patient, and then I took him upstairs and work on him and whatever else. And so ultimately, we found that he had a major, because of his alcoholism, he had a major malabsorption in his GI tract of all kinds of nutrients, which led to the fact that he couldn't make red blood cells, and therefore he was anemic. But it was an unusual case. And so we admitted him to the clinical research unit, and I had him in the hospital for like 3 or 4 months. And I did all kinds of GI absorptive studies on him to find out what the problem was. And ultimately, that became my first paper. We wrote that up as a case report, and I got to know the head of the GI division in the Department of Medicine really well, and his name was Nort Greenberger, and he was from Harvard. And he said, he took me aside one time, and he said, you know what you should do? And I said, no. he said, you should go into immunology. That's where the action's going to be in the next generation. And I never forgot that, but I had no idea what immunology was at that time, because we didn't have a course in immunology in my medical school. But that stayed with me. And so those kinds of interactions with senior people and as you're trying to move along and so forth, it's very important, I think, to listen to these people, because often they have insight and they've been where you're trying to get to. So that was medical school. And eventually I got a very good internship. And during that internship, those internship years is when I really decided that my cat's giving me a hard time. I'm gonna have to break off here. Yeah, it's sort of like that scene in the movie The Graduate, where the father of his girlfriend takes him aside and tells him, Dustin Hoffman, and tells him, plastics, this is what you got to go into. I never asked him, actually, but he was, he was astute, and he could see that that's where things were going in medicine and so forth. It's really sort of, except for the brain, the last frontier of organ systems that hadn't been really understood at all. I mean, it was as we've gone through the book and so forth, it's really was such a black box. I mean, up until the 1960s. So the thing is that so I got a very nice internship, and so I was, and because it was during Vietnam, in internal medicine was usually a 3-year training program, but because they wanted us to go over there and take care of all the people that were being shot up in the jungle, internal medicine was only 2 years of training, an internship and a first-year residency. And so, but during that time, I realized almost from day one that I didn't really like this clinical medicine business, and I didn't like it for lots of different reasons. But that set the stage for then what I ultimately did. So because after then the 2 years of clinical training in the hospital, I went to the National Cancer Institute, a branch in Baltimore. Spent 2 years there, and as I said, that was my military service requirement. First year, and the deal was that the first year we took care of cancer patients on the wards, and that was, I went on from being on call every third night as a first year resident to on call every 11th night. Well, that went a long way, and to tell me that maybe this way of life is going to be a little bit better. So the first year I was taking care of cancer patients. Second year was my first year in the lab, and that was really the first real big lab experience that I had. And I happened to be recruited to go into the lab by one of my peers, who was also a clinical associate, but he had been in the lab a year before me. So he spent 2 years in the lab, and turns out the lab was working on lymphocytes. And so, I was the second or maybe the third or fourth serendipitous thing that happened because, the mentor in this instance was Michael Martinet, who was an immunologist trained at the Scripps Research Institute in La Jolla. And my friend was a fellow by the name of Lenny Chess, and he had gone to Columbia Medical School. And the year before I got into the lab, he had worked out all the laboratory techniques and so forth. And so he really became my day-to-day mentor, particularly during the first 6 months or so of the lab. And the lab was down in the basement of the building where we were. And Mike Martinet's office, who was my boss essentially, was up on the second floor, just the way that they configured the space, which meant that I didn't have really a lot of daily interaction with Mike. Both Mike and Len Chess were from Brooklyn, New York. If you've ever met anybody from Brooklyn, New York, they are an unusual species essentially, with their Brooklyn accent and their sort of attitude is much, sort of off the cuff and whatever. So Lenny and I'd be down there and I'd be learning how to do this, that, and the other thing in the laboratory. And then Mike would come down at least once a day to shoot the breeze and find out what we were doing and so forth. But there wasn't a lot of hands-on training from Mike. As time went on, I decided that I better find my own project to do. And the first several months, I was really working as a technician for Lenny, which he really liked, because I didn't, But then as I became more competent in the laboratory, I decided that it was time for me to, do something on my own. And so in my reading, and I read a lot, and this is the first time that I was exposed to the whole immunological literature. And so my eyes started opening wider and wider as I started to learn about this stuff. And it was really interesting. I found it fascinating. At this stage, I got involved with looking at macrophages, and it was just at the time, and we've just gone through that in chapter 6 of the book, Molecular Immunity, my book. And so what I found is that macrophages seem to be very important for lymphocytes, T cells, to be able to recognize their stimulus, antigen or mitogen, and undergo proliferation. And nobody knew why. I started learning the techniques to separate the macrophages from the lymphocytes in the lab, and then was doing experiments. In the meantime, Lenny had a project that was ongoing, looking at these stimuli that had been recognized as being adjuvants, immunological adjuvants. One of them that he was particularly working on, or there were a couple of them actually, they were synthetic RNA molecules, polyribonucleotides. And so we talked about poly-AU and poly-IC. And these things were double-stranded RNA molecules, which really aren't present in normal life. And they were synthesized because they were meant to mimic the genome of RNA viruses. And it was already known, and this is why Lenny was working on them, that if you injected them into animals, like mice or rats or whatever, at the same time you immunized the animals, that you would get a markedly potentiated immune response. And so, for example, if you were measuring antibody levels, you'd get much more antibody if you injected them simultaneously with the antigen in question or the vaccine in question and this poly-IC, poly-AU. And it's interesting how that happened. It's at the time, and the other thing that was known about these molecules is that they were also very good at inducing the production of interferon. And I'll get into that in a little bit. But so Lenny was working on, so the first question he asked was, if we stick them into our lymphocyte cultures, will we get an augmented proliferative response? So he was doing that, and he was getting very good data. And so the question was, what would happen if we took the macrophages out? And when we did that, we got a markedly diminished proliferative response of the T cells. And so then we added in we added in the poly-IC and the poly-AU without any macrophages, and we didn't get any response, or it was markedly diminished. And then what we did was we treated the macrophages with the poly-IC or the poly-AU, and then added them into the cultures, and then we reproduced the original response. And so it was, and we did a bunch of other experiments, and it was clear then that the macrophages, that the poly-IC, the poly-AU, were actually stimulating the macrophages, which then somehow helped the lymphocytes. So that became another question down the line, and down the line, that something else, one of those something else's became, as maybe a decade later, that became interleukin-1. And so we did those experiments, and at some stage, Mike Martinet came down to the lab, and he found me working on these macrophages, and he threw up his arms. He said, "Oh my God." He said, "You're just spinning your wheels. There's nothing that's going to happen with that stuff. You should just trash it all and get back to the lymphocyte cultures and so forth and so on. You're spinning your wheels." And I never forgot that either. So every now and then I'd be in the lab working late at night on something or other, and I'd say to myself, "Kendall, you're just spinning your wheels." So that was and he was wrong, and I was right, and it turned out, but it wasn't a big deal, and I just and the macrophages were too mysterious, The people really wanted to know about the lymphocytes, they wanted to know about the T cell receptor, and they wanted to know about the antigen, what stimulated the T cell receptor. And the macrophages, even though they knew that they needed them, they didn't want to really know why they needed them, essentially. Lenny was going to be leaving the lab and going on to a postdoc up in Boston, and I had to decide what I was going to do. I could have stayed in the lab with Mike, but I thought maybe it was time for me to move on.